We are T.I.S, and as the name suggests, our performance will be focused on a research mission on the planet Mars. Our team consists of Elias Elali and Max Rogalski, who are our top programmers, Felix Weiss and Max Heitgen, who are our two builders, and Friederike, who, as the team leader, took care of managing the team and helping wherever needed. We will talk about following robots in this video: our main robot, the Mars rover, our tower, and the infamous Mars alien. As soon as the tower receives a signal from the RFID reader to start, it begins to raise the gate. Once the gate is fully open, the Arduino Mega 2560 of tower sends a signal to the Mars rover. To upgrade the rather basic build of our tower, we added LED stripes who signal the different stages of our base.
The first step is to import the necessary libraries. Then, the servo is defined and the motors are determined. Now, the necessary variables are determined as well as the variables to short-term values. In the setup function, one-time operations are performed to prepare the program so the infrared seeker is initialized, the camera and the necessary pins are defined. In the main part of the code, the Arduino first waits for the signal of the tower to start. After it receives the signal, it starts to leave the tower. As soon as it has left the tower, it sends a signal via Bluetooth to the tower to close the gate again. After 12 seconds, the robot stops and goes into the curve. Now, it follows the infrared signal, which leads it directly to the egg. If the infrared seeker returns a 5, the signal is straight out. If the signal is smaller than 5, it's on the left, and if it's larger than 5, it's on the right. While the robot is moving straight out, it receives a 5 from the infrared seeker. It searches with the ultrasonic sensor to see if there are any objects in front of it. If there is an object within 10 centimeters in front of the robot, it drives straight ahead for another second. Then it stops. Now it uses a camera to position itself in the center of the object. To do this, we painted a green stripe on the wall, which is then captured by the camera. So the camera now asks if it sees any trained object. It then positions itself so the object is centered on the x-axis. If the position on the x-axis is less than 145, it moves to the right via OmniWheel. If it is greater than 170, it moves to the left. When the robot is positioned, it extends its magnet arm and picks up the egg with a magnet. Then he tells the alien that it can start. Now he retracts the arm, drives briefly backward and turns 180 degrees. Now again it extends his arm and drops the egg. Then he stops with everything. Here are functions that were used to move the robot.
The alien robot, similar to the Mars rover, receives the signal which is forwarded to the Arduino via serial communication using the ESP32. The ultrasonic sensor enables the robot to detect the distance. The motor shield controls the 4 motors. It can reverse the motors and regulate the voltage. The alien itself is 3D printed, and the LED stripes within illuminate the alien sculpture.
This is the program code of our Mars station. As seen in our show, the station is started via an RFID tag. Via infrared distance sensors, it detects at which height the gate is and communicates with the Mars rover via an ESP32, which communicates via serial communication. For this, we read out the analog pins 8 and 9. In the function, we first check if an RFID card is detected. Then we read the ID of the presented chip card. In the loop, we check if the ID of the chip card matches the IDs we have stored, and then we drive up the gate.